So the next topic we'll discuss is the Clausius theorem. Okay. So it states that if a system K performs a cyclic process consisting of sequence of states and interacts with a series of heat reservoirs R1, R2, R3 like this up to Rn. So there are n heat reservoirs. Okay. At temperatures T1, T2, T3 like this up to Tn respectively, it means that this R1 reservoir is at temperature T1, R2 reservoir at temperature T2, R3 reservoir at temperature T3, R4 reservoir at temperature T4. Like this, the nth reservoir Rn is at temperature Tn. Okay, and exchanging heat energies Q1, Q2, Q3 up to Qn with them. So, heat energy exchanged from R1 is Q1, heat energy exchanged from R2 is Q2, like this heat energy exchanged with Rn is Qn. Okay. Then the theorem states that a summation over I equals to 1 to n Qi by Ty is less or equals to 0. Okay. So you have to memorize this theorem. Okay. Now we will prove this theorem. So now, to prove this theorem, let us consider a heat reservoir R0 at temperature T0. Okay, and there are n Carnot engines. Okay, C1, C2, C3. The ith Carnot engine is the Ci, and the nth Carnot engine is the Cn. Now, the C1 Carnot engine operates between. So C1 Carnot engine operates between the temperature T0 and T1, that is, it acts between the reservoirs R0 and R1. Okay, so as R0 is at temperature T0 and R1 is at temperature T1, so it is said that the C1 Carnot engine operates between the temperatures T0 and T1, that is between the reservoirs R0 and R1. Then with an exchange of heat Q1 from R1. Okay. So now is it the Carnot engine C1 is acting between T0 and T1, temperatures T0 and T1. It will exchange an amount of heat Q1 from the reservoir R1. Okay. And then similarly the other Carnot engines like the C2, C3 like this up to Cn Carnot engines operates between temperatures T0 and T2. T0 and T3 like this T0 and Tn with an exchange of heat Q2, Q3 like this Qn from R2, R3 up to Rn respectively. Now let us understand this statement by this diagram. Okay. So here you see we have this reservoir R0 at temperature T0. Then we have this reservoir at R1 reservoir at temperature T1. Then reservoir R2 at temperature T2. Then reservoir R3 at temperature T3. Then the reservoir R4 at temperature T4. Reservoir R5 at temperature T5. Then reservoir R6 at temperature T6. Like this there will be other reservoirs up to the nth reservoir Rn at temperature Tn. Okay. So, you see R0 is the common reservoir for all these reservoirs. Okay. See all these reservoirs. So, all these reservoirs are connected to this reservoir R0 by Carnot engines C1, C2, C3, C4, C5, Cn, and for the nth one it is Cn Carnot engine. Okay, so that's why this reservoir R0 is connected to other reservoirs by this straight line. It means that all these reservoirs are connected to each other by the Carnot engines. Okay, but you see here the symbol of the Carnot engine like a circle over here is not shown. Okay. So here you see we have for the first Carnot engine C1. It operates between the reservoir R0 and reservoir R1, which are at temperatures T0 and T1 respectively. So we can say that the Carnot engine C1 acts between the temperatures T0 and T1. Okay, and it exchanges an amount of heat Q1 from with the reservoir R1. Okay, and also you see here the direction of the, it is not said that what amount of heat is exchanged with R0. Okay, and the direction of the heat flow, whether this amount of heat Q1 is absorbed from R1 or rejected to R1 is not shown. It is just said that Q1 amount of heat is exchanged with R1 by the Carnot engine C1. Similarly, the Carnot engine C2 acts between the reservoirs R0 and R2 at which are at temperatures T0 and T2. And in doing so, the Carnot engine C2 exchange an amount of heat Q2 with R2. Okay, again the direction of the heat flow is not shown. Similarly, the third Carnot engine C3 acts between the temperatures T0 and T3, that is the between reservoirs R0 and R3, and in doing so it exchanges an amount of heat Q3 with the reservoir R3. Similarly, the fourth Carnot engine C4 acts between the reservoir R0 and R4, that is between the temperatures T0 and T4, and in doing so it exchanges an amount of heat Q0 with R4. Okay, so same goes for, it is similar for the Carnot engine C5 which acts between R0 and R5 and exchange an amount of heat Q5 with R5, and C6 sixth Carnot engine C6 acts between the reservoirs R0 and R6. Okay, and that is between temperatures T0 and T6 and exchange an amount of heat Q6 with R6. Like this, the nth Carnot engine Cn acts between the temperatures T0 and Tn, that is between the reservoirs R0 and Rn, and in doing so it exchanges an amount of heat Qn with Rn. Okay, so this whole system consisting of n Carnot engines with n reservoirs, okay, and one common reservoirs R0 makes up this composite system K. So this composite system K consists of one common reservoir R0, then there are n reservoirs, individual reservoirs, and n Carnot engines starting from C1 up to Cn. Okay, so that's why it is said that similarly the Carnot engines, so C1 Carnot engine acts between the temperature T0 and T1 and exchange an amount of heat Q1 from R1, and similarly the other Carnot engines C1, C2, C3 up to Cn, they operate between the temperatures T0 and T2, T0 and T3 up to T0 and Tn respectively. So C2 acts between T0 and T2, C3 acts between T0 and T3, then Cn acts between T0 and Tn with an exchange of heat Q2, Q3 up to Qn from reservoirs R2, R3 to Rn respectively. So here you see the term exchange is used. It is not said that whether the heat is absorbed or rejected. Okay.